A once-in-a-generation comet flew too close to the sun and didn't survive. A monster spiral galaxy has been hiding behind a veil of cosmic dust for 11.5 billion years, and JWST and ALMA have finally pulled it back. And 4 planets are lining up in the dawn sky right now, right outside your window. This is Astronomy Daily. I'm Anna.
And I'm Avery, and this is your space news for Saturday, April 18.
So, Avery, we've been watching Comet C-2026A1, known as Comet MAPS, for months. When it was discovered back in January, it was the furthest out a Kreutz sun grazer had ever been spotted. There was genuine excitement that it might become a naked eye spectacle, maybe even a great comet.
And then it went and died on us.
Dramatically and completely. On April 4th, Comet MAPS made its closest approach to the sun, passing just 160,000 kilometers above the solar surface, or about 99,000 miles. And it did not survive. The intense heat and tidal forces simply pulled it apart.
To put that distance in perspective, the sun's diameter is about 1.4 million kilometers. This comet was skimming just above the surface. It's a wonder anything survived at all.
For a brief moment, coronagraph images from the SOHO and GOES-19 spacecraft showed the comet going in, and then what emerged was not an intact comet, but a dust plume, a ghost. The nucleus had disintegrated.
There was a brief period of cautious optimism. Some of the leftover debris created a faint curved dust tail visible in the coronagraph images, raising hopes of what astronomers call a headless wonder, a cometless tail glowing in the evening sky.
But those hopes have now faded. The debris cloud has been dispersing, and as of today, Comet MAPS is effectively over. Its story is done.
And it is a poignant ending. MAPS was named for the 4 French amateur astronomers who discovered it: Maury, Attard, Parrot, and Signoret in their observatory in San Pedro de Atacama in Chile. The James Webb Space Telescope had even managed to measure the comet's nucleus before perihelion, estimating it at around 400 meters in diameter, about the size of the comet Lovejoy, which did survive its solar encounter in 2011.
MAPS was just too fragile, or the sun was too greedy.
But the sky doesn't stay empty for long. Attention is now turning to Comet C-2025R3, known as PanSTARRS. It's a more predictable, steadier target, no death-defying solar flyby on the agenda. And it's expected to be a good binocular comet in the weeks ahead. We'll be tracking it.
Goodbye, MAPS. You were brief and beautiful.
Meanwhile, NASA is already moving at pace toward the next lunar mission. And this coming Monday, April 20th, there's a major physical milestone happening in New Orleans.
What's rolling out?
The largest section of the Space Launch System rocket that will power Artemis III. What NASA calls the top 4/5 of the core stage, which contains the liquid hydrogen tank, the liquid oxygen tank, the intertank, and the forward skirt, is being rolled out of the Michoud Assembly Facility and loaded onto the Pegasus barge for delivery to Kennedy Space Center in Florida.
This is the backbone of the rocket, enormous piece of engineering.
Absolutely. Once it arrives at Kennedy, teams will complete the vertical integration with the engine section, which has already been in the vehicle assembly building since July. The 4 RS-25 engines, veteran hardware from the Space Shuttle program, are being refurbished at Stennis Space Center and expected to arrive at Kennedy no later than July.
And just to clarify for listeners who may have been following along, Artemis III's mission profile has been revised. It won't be going directly to the moon. The plan now is to perform a crewed test in Earth orbit, testing rendezvous and docking between Orion and the commercial lunar landers from SpaceX and Blue Origin as a stepping stone towards a crewed moon landing in 2028.
So while the moon itself is still on the horizon, this mission is critical infrastructure, proving out the systems you need once you get there. And Artemis III is currently targeting a 2027 launch.
A big visual moment for the program on Monday. Follow at NASA Artemis on social media if you want to see the rollout live.
I'll be watching.
Now, let's travel back in time, 11.5 billion years to be precise. When the universe was barely 2 billion years old, galaxies were still forming and chaos reigned.
And right in the middle of that chaos, something impossibly organized was already taking shape.
Astronomers have just published new findings on one of the most remarkable objects in the early universe, a galaxy known as ADF 22.A1. It resides in a protocluster of galaxies called SSA 22. And for years, it was just a mysterious blob of infrared light heavily veiled by cosmic dust. But now, using the combined power of the James Webb Space Telescope and the Atacama Large Millimeter Array, ALMA, researchers have pulled back that dusty curtain.
And what they found underneath was extraordinary. ADF 22.A1 is not a blob. It is a giant, structured, rapidly rotating spiral galaxy, similar to form to our own Milky Way, but nearly twice the size of typical galaxies from that era.
Its effective radius is about 22,800 light-years, comparable to local galaxies we see today. That is enormous for something that existed so early in cosmic history. The universe just hadn't had time to build something that large, according to our models.
JWST revealed the spiral arms by capturing the infrared glow of the stars embedded within the dust. ALMA then mapped the gas kinematics, the motion of cold gas throughout the galaxy. And the numbers are staggering. The entire gas disk is rotating at around 530 kilometers per second. For comparison, our own Milky Way's disk rotates at roughly 220 kilometers per second.
Though this is a galaxy spinning more than twice as fast as our own when the universe was a fraction of its current age. How does that even happen?
The leading explanation involves the cosmic web, the vast network of hydrogen filaments that connects galaxies across the universe. ADF 22.A1 appears to sit at the core of a protocluster that's being fed by these filaments. Cold gas flows in from the cosmic web, imparting both the raw material for star formation and the rotational momentum that spins the disk up so rapidly.
The galaxy is also forming stars at an explosive rate, hundreds to thousands of times faster than the Milky Way does today. It's a monster galaxy in the truest sense.
And the latest study goes further, examining not just ADF 22.A1, but 9 dusty star-forming galaxies in the same protocluster region, giving astronomers a broader picture of how the most massive galaxies in the early universe built themselves. The results suggest a surprising diversity. Some are in active bulge-building phases, others are disk-dominated, and the cosmic web appears to be the common thread driving them all.
We'll link to both the ALMA press release and the journal paper in our show notes. Truly stunning science.
Still in the realm of astonishing astronomy, let's talk about a planetary system 372 light-years away in the constellation Pictor that is doing something astronomers have genuinely never seen before.
Tell me.
A team led by Ismael Mireles, a PhD candidate at the University of New Mexico, has just published findings in Science Advances on a 3-body system called TOI 201. And what makes it extraordinary is that the orbits of all 3 members are changing fast enough to be observed in real time on human timescales.
Which is almost unheard of. These things usually take millions of years.
Exactly. The system contains 3 very different objects. First, a super-Earth, TOI 201d, about 1.4 times the size of our planet and 6 times its mass, completing an orbit every 5.85 days. Second, a warm Jupiter, TOI 201b, a gas giant about half the mass of Jupiter, orbiting every 53 days. And third, the troublemaker, a brown dwarf, TOI 201c, on a wide, highly elliptical orbit of about 7.9 years.
A brown dwarf is that in-between object, too massive to be a planet, not quite massive enough to ignite fusion and become a star.
Right, and in this case, the brown dwarf's immense gravitational pull is actively warping the orbits of the inner 2 planets in real time. The team first noticed that the warm Jupiter was arriving at its transits, its crossings in front of the star, about 30 minutes late. That gravitational shudder was a signal that something was pulling on the system.
And the implications of these changing orbits are dramatic.
Within about 200 years, the super-Earth will stop transiting its star from our viewpoint entirely. The warm Jupiter will follow a few centuries after that. The system is actively reorganizing itself in front of our eyes.
which also means we caught it at a very particular moment in cosmic time.
A lucky window. And the TOI 201c brown dwarf has another distinction. It holds the record as the longest period transiting object ever discovered. Its next predicted transit is March 26, 2031, a rare opportunity for a worldwide observing campaign, including amateur astronomers.
The discovery required collaboration across 3 continents: tests from space, the ASTEP telescope at Antarctica's remote Concordia station, and telescope networks in Chile, Australia, and South Africa. We'll link to this Science Advances paper in the show notes. And now, your alarm clock challenge for tomorrow morning, because right now, 4 planets are gathering in a tight cluster in the pre-dawn eastern sky, and we in the southern hemisphere have the best seats on the planet.
Mercury, Mars, Saturn, and Neptune, all fitting into a patch of sky just 4 degrees wide. That's about the width of 3 fingers held at arm's length.
Neptune you'll need binoculars or a small telescope for, but Mercury, Mars, and Saturn are all naked-eye targets. Mercury is currently the brightest of the group at magnitude -0.1, quite striking.
From Sydney, Melbourne, Auckland, Perth, look low in the east starting about 60 to 90 minutes before sunrise. The cluster sits near the border of Pisces and Cetus. Make sure your eastern horizon is as open as possible.
The good news, this isn't a single morning event. The peak viewing window runs from roughly April 16th through 23rd, with tonight and tomorrow morning being the absolute prime. If cloud cover spoils it for you, you have multiple more chances this coming week.
A stargazing app like Starwalk 2 or Sky Tonight will show you exactly where to look from your specific location, and it's completely free to step outside and look up.
Set that alarm, you won't regret it.
And finally, we're going all the way back to the early universe, about 10 to 12 billion years ago, to an era astronomers call cosmic noon, the peak epoch when galaxies were growing their stars faster than at any other time in history.
And there's been a long-standing mystery here. All that star formation requires enormous amounts of hydrogen, but astronomers couldn't find it.
Until now, the Hobby Eberly Telescope Dark Energy Experiment, HEDEX, has published a landmark study in the Astrophysical Journal, identifying more than 33,000 massive hydrogen gas halos, called Lyman Alpha nebulae, surrounding ancient galaxies from that era.
33,000. What was the previous count?
About 3,000. So this study has increased the known number tenfold in a single survey. And what this tells us is that these hydrogen halos are not rare or exotic. They are common features of early galaxies. The fuel for cosmic noon's explosive star formation was always there. We just finally have an instrument powerful enough to find it.
The lead researcher, Aaron Mentich Cooper, described the halos as giant amoebas with tentacles extending into the cosmos. And HEDEX was specifically designed to hunt for the Lyman alpha radiation signature, the characteristic glow that hydrogen produces when energized by the ultraviolet light of nearby young stars.
It's a beautiful piece of science, and the implications go beyond just accounting for the hydrogen. This discovery reshapes our models of how galaxies grew during their most productive era. The raw material was not a limiting factor. It was everywhere, in vast, glowing clouds surrounding every major galaxy.
A reminder that sometimes the universe is not hiding its secrets. We just need bigger eyes to see them.
And they're indeed getting bigger all the time.
Time for today's astronomy trivia question. Avery, hit me.
All right, Anna. Today's question. Comet MAPS was a Kreutz sungrazer. What are Kreutz sungrazers, and what ancient comet are they all thought to be fragments of?
Okay, I've got this. Kreutz sungrazers are a family of comets that all follow similar orbital paths and pass extremely close to the Sun at perihelion. They're believed to be fragments of a single massive comet that broke apart roughly 1,700 years ago, sometimes linked to the Great Comet of 371 BC, which may have been the original progenitor body.
That's exactly right. Named after German astronomer Heinrich Kreutz, who first cataloged their similar orbits in the 19th century. There are more than 3,500 known members, most of them tiny, discovered only in SOHO coronagraph images as they flare briefly before vaporizing. MAPS was one of the rare ones large enough to be spotted far from the sun, and one of the rare ones large enough to generate real excitement, even if that excitement ultimately ended in heartbreak.
I love trivia questions. I think we'll do more of these.
I'll see if I can keep them coming then.
And that's your Astronomy Daily for Saturday, April 18th. A fallen comet, a monster galaxy unveiled, a planetary system changing shape, 4 planets at dawn, and 33,000 cosmic halos illuminating the early universe. It's been a big week for the sky.
We'll be back Monday with the latest. In the meantime, find us at astronomydaily.io and on all major podcast platforms. Make sure you subscribe so you never miss an episode.
I'm Anna.
And I'm Avery. Keep looking up.